Hi, so today I want to talk about the sine and cosine rules. Okay, we essentially use sine and cosine rules to find an unknown side or angle in a triangle. So these are cases where we cannot directly apply the Pythagoras theorem. So for example, let's say we had a triangle. Okay, this is a right angle triangle, so that's 90 degrees. This is A, this is B, and we want to find the value of C. Then obviously by the law of the Pythagoras theorem, c square is a square plus b square. It's very easy to find this unknown side. So this would be one case where there is a right angle triangle and we're finding a side. The second case we can have is possibly, so we have a right angle triangle here, and we are asked to find this unknown angle given that this value is A, this value is B, and this is angle C. The angle here C. We want to find the angle C based on the values A and B. We can simply apply the law of tan. So tan C will be A over B, and C is the tan inverse of A over B. Okay, so these are two cases where there are direct right angles and we do not need to apply these special rules. So we can either just do the Pythagoras theorem or apply the law of sine and cos, like the opposite of a hypotenuse, adjacent of a hypotenuse, those are laws. So these are two cases, but sine and cosine rules are for the third case, where we don't have a right angle in place. So we cannot use Pythagoras, and we also cannot use the law of sine and cos. This is because there is no right angle. So now we're going to specifically focus on case number 3, where there's no right angle and we need to find the value of a side or an angle. Okay, so I'm just going to give you the formulas first, then I'm going to talk about what types of triangles in which we can use either the sine or the cosine rule. So first I want to give you the actual sine and cosine rule, then I'm going to talk about where to use each of them, what types of triangles to use each of them. Okay, so let's start with the sine rule. So it's sine angle A over small a is equal to sine B over B is equal to sine C over C. So in what type of triangle would this sort of equation apply? So we can imagine a triangle like this, any triangle. This should be a scalene triangle where there are three angles. Excuse the drawing. Three angles. One is angle A, one is angle B, one is angle C. See, the angles are indicated by an uppercase letter, and the side that is directly opposite to each angle is the smaller case version of it. So A would be small a, B would be small b, and C would be small c. So in this sort of triangle we can apply the sine rule. Now let's talk about the cosine rule. A square is equal to b square plus c square minus 2bc cos a. And in what type of triangle would this apply? We have a triangle like this. A is the value of a side, so technically A can be any side. Yes, I'm just gonna make this A, and B and C are the other two sides, B and C. And A, the capital letter A, as I've said before, is the angle directly opposite to the side A, so that will be A. Okay, so in order for us to find the value of side A, we need to know the values of B, we need to know the value of C, and we need to know the value of angle A. Then we can find the value of the side A using the cosine rule. If we were to find the value of angle A, and we have A, B, and C, then we can also use the cosine rule. All we need to do is a bit of substitution and rearranging this equation. Then we can find the value of angle A using the sides A, B, and C. Now let's have a look at the types of triangles and in which triangles to use each case. Okay, so what do each of these mean? So A represents angle, S represents side, and A represents angle again, which technically means that this side is between two angles. So let's say we have a triangle, any triangle, and what we are given is two angles and one side, but the positioning is important here. You see, so if the angle is here and the other angle is here, then the side has to be here, because the side is adjacent to both angles. So that's what it means when you see the S between the two A's. So now what if the A is between the two S's? So we have two sides and one angle, same triangle. So we have one side here, we have one side here, and the A being in the middle represents that this angle is between these two sides. So that is the A. So let's say we only have three sides, SSS. There's no angle. We're not given any angles in the question. So then there would be a triangle, and then we have S, S, and S. So there were no angles given, but we have the values of all three sides. So we can use the values of all three sides to find the value of any angle we are asked to get. Then we have SSA. SSA represents that there's two sides and there's one angle, but the angle is not submerged between the two sides. So we can have the angle here, perhaps, yeah, the angle could be here, A, and we could have the sides, two sides here, or we could also have a triangle A, and this could be the S and this could be the S. So as long as the angle is not submerged between the two S's, SSA can apply to both these triangles. And then we have AAS. Okay, we have two angles and we have one side, but the side is not submerged between the two angles. So it is basically a variation of ASA. But in this case, the angle could be here and the other angle could be here, and this could be the side. This could be the side, or this could be the side, perhaps. So this side is not adjacent to both these angles. So this could be the angle, this could be the angle, but instead this is the side. We have two angles and one side, but the side is not between these two angles. Okay, so we have different types of triangles, different types of scenarios where we're given a different number of sides and angles. So in which case do we apply the sine rule, and in which case do we apply the cosine rule? Now let's have a look. So for SAS and SSS, we apply the cosine rule, and for every other scenario we apply the sine rule. Okay, now let's apply this directly in a question.